Hello, everyone. My name is Martin Sapp, and today I'll be talking about social bias frames, reasoning about social and power implications of language. And this is work with my co-authors Sadia and Liang Hui, as well as Dan Jurafsky and my two advisors, Noah Smith and Yejin Choi. And before I go any further, I just wanted to warn folks that because we're talking about social biases and stereotypes, the content in this presentation may be upsetting or offensive. And when we're talking about social, inequality, et cetera, we're going to approach it from a US social cultural perspective. So when people talk about bias, there's usually two ways that we can differentiate these biases. One is a overt way, for example, we should kill all gays, which is easily flagged as toxic by existing toxicity detection tools such as the Perspective API. But then there's a more subtle bias, like we shouldn't lower our standards just to hire more women, which implies that women are less qualified than men and therefore is problematic, but yet is fully missed by toxicity detection systems. And so social bias frames is a new structured formalism that distills knowledge about harmful and biased implications of language, no matter how overt or subtle these biases may be. And specifically what our frame looks like is it first asks whether a statement is offensive or not, here it is, whether it was intended to be offensive, here maybe, whether the post is lewd or sexual in any way, here it isn't. And if it is offensive, we're going to ask, is this targeting a specific individual only, or does it actually have biased implications about a group? Here in this case, it is about a group, and that group is women, and it implies that women are less qualified than men. And then finally, our frame ends with a variable asking whether this is a case of in-group language, where, for example, a woman would be speaking about other women. And in this case, it doesn't seem to be the case. So the motivation for our work is that AI systems need to understand social dynamics, and societal inequality in order to interact in our inherently social world, because otherwise they can backfire. And binary hate speech detection is not enough to make models reason about societal inequality, partly because what makes hate speech actually depends on who is annotating these things, but also because there are a lot of biases against minorities in these binary hate speech detection systems. So we also think that social bias frame style explanations can actually really help, not only to help understand what the harmful implications are of text and maybe even increase empathy towards the targeted groups, but it can also help increase the trust that users have in these systems by providing an explanation beyond a toxicity percentage. So, social bias frames is inherently a frame formalism. However, in contrast to more denotational formalisms like FrameNet or PropBank, our work is more about what is implied and therefore more in line with connotation frames. It's also related to common sense inference. However, in contrast to, for example, ConceptNet, which focuses more on physical common sense, it's more in line with Atomic in that it focuses on the social common sense implications of text. And then finally, it is also very related to existing, toxicity detection resources like binary toxicity detections. But in contrast to those, ours is a frame and therefore inherently structured. And comparing to more recent work like microaggression detection or condescension detection, our work covers both overt and subtle types of biases. So in this work, we also introduced the social bias inference corpus, which contains 150,000 tuples that were annotated from 44,000 posts from social media. And these annotations of this corpus covers 34,000 implications about 3,000 different demographic groups. So the goals that we had when we were collecting this inference corpus is that we wanted it to be large scale and good quality in order to enable neural modeling. And we did this by training our annotators and crafting up a crowdsourcing framework. But we also wanted the types of biases in our corpus to reflect the real world biases and also have high coverage. And so for that, we were very careful with the data sources that we selected so that the biases were both overt and subtle. And glossing over the data sources that we used, we turned to Twitter Corpora for hate speech detection, also Reddit Corpora for more subtle offensiveness, and finally hate sites for more overt biases. And when it comes to the groups that are targeted by the posts in social bias inference corpus, we actually see that the top three groups are Muslim and Jewish folks, Black and Latinx folks, and women and gay men. And while this is really heartbreaking, this is actually reflective of the types of hate or offense that people report experiencing in the real world. So that's good news. So I will point to the paper for more details on our crowdsourcing framework, as well as details on the annotator agreement metrics, and also as for details on the theoretical groundings in psychology, pragmatics, and rudeness of the way that we design our frame. And instead, I'm going to focus here on our modeling case study, where we asked whether NLP models could learn to make inferences about posts using social bias frames. And so specifically, we wanted to see if models could predict a social bias frame from a previously unseen post. And this requires a model to be able to both classify categorical variables, but also generate the groups and implied statements. And so a natural model for this would be a GPT-style transformer model. And so that's what we did. And we linearized our frame first and passed it through a transformer. And then in a causal prediction sort of way, we just optimized the cross entropy of all tokens at training time with adding special tokens for each classification variable. And at inference time, we're going to frame this as a conditional language generation task by autoregressively token by token generating the social bias frame. However, as you may have noticed, this could lead to generation that could be inconsistent with the frame structure. That's because the structure isn't always learned properly by these models, and so you can end up with a post that is predicted as not offensive, but still has the model predicts that there's implications about groups. And so what we need to do here is enforce the structure post hoc, which you can do naively by just enforcing the structure top down. Or we can do something more global by, letting the future decisions correct the past decisions that we've made, for example, by flipping an earlier decision that we've made. And so when we look at the classification performance on our classification variables, we actually see that this type of constraint inference actually helps. And when we take a closer look at the classification performance and breaking it down by all of the classification variables, we do notice that the lower level variables are a lot more challenging than the top level variables. So glossing over the automatic metrics for generation, I'll just note that models tend to identify the targeted group well, but that the models can't really spell out the implications, especially when they're subtle. But I think it's more striking if we look at examples to see what models may be doing. And again, warning, the next slides may be upsetting. So here's an example that says, I love gay guys, they're so much fun. I would love to have a gay guy best friend, but lesbians are just annoying. And here the model that's trained on our social bias inference corpus predicts that this is offensive to lesbians because it implies that lesbians are annoying, which is in line with what the annotators wrote. However, the annotators also noted that this is offensive to gay men because it implies that all gay guys are fun to be around, which is a much more subtle implication here. And so, models can be successful, but it might be due to lexical cues or keywords like the word annoying here. Here's another example where a black guy is in class and attempts to throw a paper ball into the trash, and he misses, and his teacher says, "You're a disgrace to your race, Marcus." Here, the model does think that it's offensive and that it's offensive to black folks because it implies that black people are trash. And this is not at all right, because that's not what the annotators wrote. In fact, the annotators here wrote that this is offensive to black folks because it implies that black men are good at basketball and that black men are defined by their athletic skills. And so again, this is another case where models might be relying on negative keywords to make their predictions and using identity mentions as also a hint as to who's being targeted by the posts. So some quick takeaways for our work is, we introduce social bias frames as a new structured formalism to distill bias implications in language. And we create the social bias inference corpus, which contains 150,000 annotated tuples, which you can download at this URL. And, we show through our modeling experiments that, better, more structural modeling might be required in order to do this type of reasoning that the social bias frames capture, because the full frame prediction is actually quite challenging for the models to do, especially the lower level variables. And models seem to struggle to distill subtle implications and instead relying more on lexical associations to make their predictions. And really, we hope that this encourages further work to proactively measure and mitigate social biases in text. And thank you so much for listening.